in the later stage when we are focusing on how to handle multiple users. Right now, since our Node.js instance is single-threaded, right? So it'll be able to handle multiple requests. But for if for concurrent requests accessing a specific resource, we'll have to make it thread safe.
Hey, my take was that the issue here is what you say, but also you should be logging and maybe using performance counters or some way of measuring machine stress so that, when you see machine stress, you're prepared to scale out the services. So it's not only are they scalable, but do you have the mechanisms in place to see that you should scale out?
So while I was researching about this, I've heard that Node.js is the best thing. Like, it's the best available framework for scaling, like compared to other platforms. And from what I could understand, the reason is because of there's a library which allows us to manage all these things. And I'm going to go through that probably in code if I get some time. Basically, yeah, that's like, so consider our example, right? We built a test harness, right? And so we had a blocking queue, which was a static blocking queue, and it was shared by all the instances, right? And inside it's a single-threaded, the instance is single-threaded, right? It's in a single-threaded apartment. So we are not actually, it's not like a multi-threaded environment, right? It's different, but it acts like a multi-threaded environment because it's managing all those different requests and
Yeah.
and by making use of those processes, it's managing.
A node allows you to spawn out.
Yeah.
So one of those processes can spin out a callback, and let that callback go and do heavy lifting on a child thread, and then call back. And the callback is just a request coming back into the node queue. So
that depends on what kind of application you're building. If you have something like an audio processing going on, image processing going on, or video processing going on, you want it to be a separate process so that it becomes multi-threaded. It's a single-threaded environment, but it acts like a multi-threaded environment.
any one of those requests, the activities can spawn a child thread. It doesn't have to be another process. It could be a child thread, but you can't block. Just so as long as you can't block the main guy, it's got to be keep service.
That's the thing with MongoDB instances, right?
Yeah.
The next part is the tools and technologies. So we mentioned this last time also, and we have the same. We're still using the same languages, same tools. For Python, we are using Flask. It's a micro framework, web framework, Python, based on toolkit. And we are also using JavaScript. And I'm using d3.js and chart.js for building visualization tools. For setting up visualization. And then I'm using C++, tiny HTTP server for building a monitoring tool. And I have my database. For my database, I'm using MongoDB. And I'm also building a C++ in-memory JSON store. It basically is just a parser, which allows me to parse a JSON object and store that JSON, those values which I need to, and query if I delete them.
I have the idea that Redis does something like that. Redis is a totally in-memory.
It's an in-memory data store.
Yeah.
And it's basically allows you to do caching.
Yeah.
So you usually when you're building an application, web application, Spring MVC or maybe ASP.NET, I'm not sure about ASP.NET, but you use Redis or Hazelcast. They do caching for you. You don't need to do work. You don't need to do processing again. Do some work and get some results. Those results are saved in an in-memory database, and you can just get those results back. Skip the processing. Just like some math. Okay, so next step. So this was the earlier design which we were looking at for our project. It's still the same. Most of the things are the same. And what I am focusing on is the notification service, the database, building schemas for database, and the monitoring tool specifically, and all these services, for the job posting and for the messaging, all of them are just Node.js services. I'll talk in detail about these.
Arpit making progress even though he's doing a lot of interviewing? Is he still?
I haven't heard from him about it, but I think yeah, he's working on it. He's working on the authentication part. So the next part, let's talk about the services. What each service is doing. So the first service is the monitoring tool service. And it has three parts in it. It has visualization, logging. It's responsible for logging, and it's also responsible for testing other services. It's basically monitoring other services. Then the second service is the job posting service. It's based. I'm building it using Node.js. What I basically want to do is just add, query, or remove a job posting. That's what I want to focus on. And then the push notification service and event notification. This is subscriber-based service. So if you subscribe to a service, you'll be any event that occurred for that specific service will be sent to the will be attached to the basically they'll be attached to the ID of that user, and that user will have access to other information. So the next service is the tech event hosting service, which is same as job posting. It's an Node.js service. So I'll begin with the first group. I'll start with a Node.js and MongoDB, which I wrote. So first I'm going to just open.
Could you go back to that slide for a minute,
Sure.
just so I can? So
I'm using this probe to demonstrate. I'll need it for building my job posting and event hosting services, right? Because they are based on Node.js. So I'll need the save and delete data operation using Node.js. Save and delete objects from MongoDB. And then basically I want to do is build helper functions, which allow me to do that. And I want to delete specific values. So these are just a set of functions that allow me to do that.
So all you guys doing, when you do the probes, don't skim through this too quickly.
Okay.
You want to really tell it, we want to understand what you're doing. Otherwise, the code just kind of goes over our heads. Yeah, good.
So I'll start with the demonstration. So the first thing what I'm going to do is set up MongoDB.
Both Mongo and Node play well with Visual Studio.
Don't mind, could you increase the concept?
Yeah, I'll do that. Is it visible? Is it fine right now, or is it like you watch
A little bit of.
A little bigger would help.
Okay.
Also, when you're talking, Colin, could you kind of raise the volume a little bit and project outward? If you talk to the last row, we'll be in good shape.
So now my MongoDB is set up. I'll try to increase that one. Even if you know how to do that.
Down in the, see, your layout is a little different than mine, but usually there's a little place right on the lower left corner, but I don't see it.
Can you go to set?
Control Shift Control P.
Control Shift P. Control Shift P.
Type settings.
You can just type.
Type settings. Open user setting. Font type.
Yeah,
Yeah,
make 18 or
move
something.
that to the right side.
Make the value 18 or something.
That's 14.
Yeah, the same thing.
Click
You
on
just
this.
You just copy and paste on
Copy
the
to
right
the
side.
right side.
Did somebody come up and I haven't done this.
We don't want to get too wrapped up in this, but
size for us and visual code.
Okay, I hope it's visible now.
Thanks.
Let's start. So I just set up my MongoDB. Now, okay, now I'm going to start the application. So there's no error. So it'll be fine. Otherwise, it would have shown me some error because MongoDB connection failed. So this is the basic layout we are using. Right now I'm serving it on Node.js, but in the later stages, what we are planning is trying to use Spring MVC because that's what that's Arpit's part. So we'll be basically using these content pages and serving it on Spring MVC. So that whenever a user logs in, he authenticates himself and logs in and saves that information in the MongoDB database. So what I'm going to demonstrate is just how the communication with the MongoDB is. So I go to job listings and I have this form here. So let's go to the MongoDB. Let's see if I do this, I get a list of connections which I have stored in my MongoDB, and I can just select any one of them like this. Then what I can do is this will give me a list of values which are there in the database. So now what I want to do is just add a job, right? Just create if I'm a recruiter, I want to post a job. So I'll specify the company name. That's the name of the company and the type. If it's a telecom, if it's an IT industry, I can just do IT. That. This item is saved. Now if I go to my MongoDB instance, if I go to my MongoDB instance and do this, you'll see a new item added to this. So that's how we add data to our MongoDB. I'll just demonstrate with another collection. This collection, right? I'll demonstrate how to delete a category, how to add a category. So suppose I'm adding a category. Let's name it something. Already have this. So here, right now, go to place. I'm switching. And see the name added. So I'm going to delete this now. Demonstrate how to delete it. Go back to my database. So yeah, this is how basically it goes. Like I just walk through the code. You get a sense of what I'm doing right now. These are just routers allow me to basically do operations. So right now I was making changes. I was using the category route and the user route. If I look at the category route itself, I go to API category, look at this controller. I can see the set of functions there which basically define what I want to do in my application. So if I'm posting anything, my MongoDB instance. This is what I do. So, okay, so this category is a schema. This I define the schema here itself in the model, and I make use of this schema by creating an object or basically a class, right? It basically allows you to, it's a property, and basically allows me to manage my database, manage how my values are being stored, what type those values are, and how are they default, or are they constants, things like that. Are they within a certain limit, or are they, like, if I'm putting age, I want it to be between one to 100, so I can put that limitation in the schema itself. It won't allow me to set a limit, set a age higher than 100, things like that. So this is the category. And anyone has any questions? So back to the presentation. So, yeah. So okay. If you want to see other functions also, I have other functions also. I think this is enough. What I can tell you right now is there's an option for me to, like, delete or delete many, delete one or delete many. So it allows me to do multiple deletes, and delete one does only one delete. The first value it encounters. So I'll go back to the next step, next probe. Now what I want to do, in this probe, what I want to do is test the API, right? The test Node.js and the C++ and Python API. What I want to do is test the intercommunication between these services. So
I have just one question regarding the previous thing. I know how to run the server hosted from the Node.js, but how do you run it from Visual Studio Code? I don't know about that.
So just go to this folder itself, open the folder itself, where your project directory is. So just set up Node.js. First thing is you want to set up Node.js npm. Then what you want to do is just click here, open in command prompt. It will open the path where your file is, and here you can just start running. Just run this command node and whatever script you're running.
It's like it spawns terminal inside it.
Yeah, it just opens a command window inside that. And basically this is a Git terminal, which will help you manage your project. You get the project result. Makes it easy to use. Makes it easy to manage the project.
Thank you.
Is that okay?
I think the server is already running, so probably that's fine.
It's already running.
It's already running.
But I should have stopped, right? All of this. Yeah, I
You need to close that browser probably, command prompt.
So now I'll demonstrate the Python. Now I'll demonstrate the intercommunication between the different services, the Node.js service, the C++ service, and the Python service. So let me first host the Python script. So this is my Python script. There's a lot of stuff in here. So these are routes, as exactly like what I had in Node.js. I don't have, I'm not building routers here because I don't need to. It's a small service. And, allows me to do certain tasks which I want to do. So I'm going to host this service right now. So this allows me to host this service. And the next step is this route. If you can look at this route, this is, I built this route to basically just test if my service is working or not. Basically, this service is running in the background, right? And I want my Node.js my monitoring tool to test if, what all services are still operating. So I can just do this, just run put a GET request and check if the service is still functioning. It will return an error code if it's not working well. And I can build other test cases also. It depends on what other things I'm doing. So I go back to this, open the monitoring tool. So this monitoring tool has a speech to text, building a speech to text service. Basically, I wanted to make it more interactive. So if I say test CPP, it will do the test. It'll run a GET request to that server to my C++ server, and it will give an error if there's an error if it's not running or not. So yeah, some things like that. And test, if I do the test Python button, it should test these buttons basically allow me to get requests to my service. So I'm going to test the Python service. So it gives a success. If you look at this console, go back to the console. If I do this, I'm getting a response message. If I go to my Python service itself, I'll see I'm getting some GET requests, right? These are GET requests from my Node.js server. So that's how I'm able to monitor and keep track. And I can do other things also. In later stages, I'm planning to do other things. So, okay, let me open the
It is ultimately your voice picking, right? Your command is being picked by the voice.
right now, yeah, I'll demonstrate that.
So basically what you've done, you've loaded a module into Node that knows how to link to Python and accept scripts and stuff like that.
No, what I've done is basically build a speech to text microservice. It's a separate service.
Okay.
What I do is I stream my audio in OGG format to my service, and it passes that data and it returns a text. That text is the speech. So after I get the text, I can basically, after passing the text, I can do the test, the specific test which I want. If it's a C++ or if it's a Python server test, I can specify. And I have to build a parser yet. I haven't done that. So I'll just start with this server. So I haven't worked on this a lot, but I'll just demonstrate.
Remember from, you took design patterns? You did, didn't you?
Yeah.
Never apologize.
Just send
You're doing fine.
I'll just send a test request.
Really very tough. Apologize when you go wrong. It's really very tough not to apologize when I really go wrong.
Yeah, but it's better not to.
So as you can see, I got a request from my Node.js server. This is the message I get. We receive the request and the message testing C++ server, and the plus plus has been encoded. And this is the response message which I'm returning to my Node.js server. So yeah, I just wanted to demonstrate how I'm communicating across different services. What I'm planning is I'll have a JSON store, in-memory JSON store along with my C++ server. So any JSON object which I send to my server, will be able to parse it. Right now it's not doing that. So I want to be able to parse the JSON object and just use that information in my monitoring.
Are you doing this for speed? I mean, Mongo basically will holds JSON.
Yeah. I had an interview where they asked me to build a JSON in memory store, and I was working on that a little bit, so I thought, why not just integrate. I can try MongoDB, but I
No,
already
I mean,
done
it
that in
would
Node.js.
probably make a whole lot of sense from a performance point of view to do just the way you're doing it, I think.
Yeah, it's much easier to do, right? Because I can just, I mean, there's a lot of things.
Yeah.
So I demonstrated this communication between different services. And I'm printing the results, I'm doing a status check. Right now it's just an alert button, alert box, but later I'm planning to do check boxes where it will just show that services are online. And yeah, so the next step also is I mentioned is explore clustering, which is master and workers and Node.js services. So I'll give a demo because we have time. This is what I found. If you look at this, what it's doing, this cluster, what it does is it spawns workers using the fork method, this fork method here. And this means workers can share server handles and use inter-process communication to communicate with parent code process. So there are a lot of ways to communicate in these processes, and Node provides us a way to do that. Right. If you guys are interested, you can. This is a lot of these are kind of things which we can do. So there are certain events which are occurring, right? There's an entry event, there's an exit event across all those processes, and what we can do is send these events across the master and the workers, and notify the master process that this event occurred, and you can using these commands you can basically communicate.
They're essentially callbacks into the main node queue, right?
Yeah. That's what I'm guessing. They have a queue in the backend, but they don't show that. Very clean code. So next row. So the next part of for my task is building a visualization tool, right? So I want to visualize the data which is stored in my MongoDB instances. I'm making use of tools like d3.js, chart.js, basically to visualize the data. And what I want is I want to request data from any node service, and it will give me I'll get the data and save it in a CSV file or a JSON file. And then in my monitoring service, what I'm going to do is parse that JSON and visualize it. So I'll give a few samples. This is the D3 script, right? So if you look at this, right now what I have is static data, and in the later stages, what I want to do is I want to make an AJAX request. I want to make an AJAX request, which basically allows me to fetch those values from my services, Node.js services, which I'll be hosting. So right now I'm showing it just to demonstrate how it will look like in later stages, what I want to visualize, what kind of data I want. But I just want the number of applicants for specific companies, and what I do is I build my own data, dummy data, to demonstrate it is how I can use dp.js to visualize this. And if you look down, this is how it works. dp is it allows me to build a chart. This is how you set it up. These are the attributes. And then you can also define the style. This is an example for. I was actually I wrote the name wrong. It's not a pie chart actually. I'll change that. Then I'll show you. This is also static. I look at my script. So these are different nodes. I'm just defining, just building these nodes and then defining the relationships between these nodes. You can see the relationships there. So 0, 1, 2, 3. With this has a relationship with these nodes 0, 1, 2, 3. That's how we can. Later, I'm planning on basically building a graph. What I'm planning is I'm going to pass that JSON. I'll be writing a script, which what it will do is it will pass the data, which will probably be a CSV file or a JSON file. It will pass that file and build a graph object, and then I'm going to load that graph object in the here itself.
Can you just tell me like how does it plot the data? Like which is the function
It's
that's
a
actually
library. It's a library. Yeah, I'm not. You can look at. So, okay.
it's a library in the D3.
Yeah,
D3.
it's a D3 library, and you have to write your own script. It allows you to build charts. It's a like you have an object and you're adding attributes to the object.
For the graph, I was
Yeah,
talking.
yeah. D3 is an object, right? It's that graph itself is an object. You're adding attributes, you're defining properties. And in the end, is what you get. I'll give you I'll show you the script.
It seems much easier. Like we are doing a social media mining class where we are using bokeh, which is very complicated for the same functionality. D3 seems much easier for the same job,
Depends.
especially for the graph. Like
I think the harder part in your course should be how you're processing the data, how you're building the relationships between the different data. The visualization tool is the next step. I think in JavaScript, they have made it other. So I forgot to demonstrate that.
You're getting close to the end.
So should I do this right now?
No, you got 10 minutes or so.
Let me just finish it if I get time. I'll finish the presentation if I get
Yeah.
time. So yeah, this was my third probe, and Arpit will be demonstrating the authentication part and how he's defining the user attributes, and what kind of database he's using. He'll be finishing up the authentication. Okay, so let's give a brief summary about the probes which we have just took place, which I demonstrated. So in the first probe, I demonstrated MongoDB and Node.js implementation, right? Now that we have MongoDB set up with some basic schemas, we can start designing our message structure. Message structure should be preferably similar across all services. So what I mean by this is, I want intercommunication between different services, and I want them to process data, right? I want that data. I don't want too much complication while doing the processing. So I want it to be standard across all the services. In the second probe, use the speech to text service to run a set of test cases. So what I'm doing right now is it's just returning the text. Later, in the later series, what I want is to do the execute the parse that data and execute the specific test which I want to do.
That has to be a very clear.
No, I mean it worked out.
So-
If I say test 1, test 2, it passes test 1. I'm using Google Speech API, so they
Okay.
have-
If you had lots of test cases and there were,
specific names.
yeah,
I mean, it makes no sense to build this, but I built it anyway.
interesting idea. Like that.
I wanted to make it. I still want to add the visualization stuff. Build it all together. Right now it's all separate. So the second pro use the speech to text service. Second part is build a UI where admin can test all the services. Or just add more test cases. But I haven't thought about this part. How I'll do that. Adding more test cases. How admin can add more test cases. I'll think about that. The third pro, next steps will be to make the T3 graph dynamic and populate them using the data from MongoDB. As I mentioned, will be how I'll do that.
For the test cases, you could, the dispatching model might work really well, so you got a dictionary and you have a ID for each test case, and then it does what it does based on, that's an easy way to make it extensible.
Something like that. Okay, so the last step is generate data set and store it in MongoDB. I'll have to create a lot of dummy data.
What kind of data do you expect to be putting into the graph? I mean, so you're trying to monitor what's going on, right?
In my demo, I gave you an idea, right? I mean, what I want is number of applicants for each job, specific job, for each company, and I want all those companies to be divided by the category, associated with the category. If it's a tech, if it's an IT industry, it will be associated with an IT industry.
I see.
Things like that.
I got the graph part. I got the the bar graph part, but I wasn't clear what you were doing with the.
That's just one sample. I try to add.
Is and vertices. Yeah. Okay.
So let's in the final comments, I'll just give you my brief estimates how much time it will take for me to finish. As the monitoring tool, I'm planning to finish by 28th next month. I think most of the things are done using the d3.js library. And, the test cases, I'll have to add the test cases myself. And then the performance part, I want to basically get network data information, which is possible to do it using Node.js APIs. It allows gives me information about how much bytes are passing through.
Okay.
So I can display that data. I can send the data to monitoring. The notification part, which is capturing DB updates for specific users. Basically, users who subscribe to a service, they can get updates. Then the job board listings, you create a job. This is a Node.js service. Create a job, add attributes, and you can just filter by querying to database. And the tech event is also working exactly the same way. It's a Node.js service. Exactly. Anyone has any questions?
Any questions or comments? Good, thank you, Mel. Okay, go. Oh. Okay.
Something like that.
You're kind.
One.
Your HDMI? Your Mac? Nope. HDMI. Not muted. Duplicate is what you want. Just a minute. Just the input, there's just not the just toggle it to get it. It's not seeing your HDMI. Let's just try. Right. Oops.
A little kick. Right. Cool. And this is the probing demonstration from my project. Is titled Cross-Platform GUI using Chrome 10HB Server. It's been a few weeks, so the actual content actually doesn't reflect the Chrome part, but the whole thing still stands, so I'm going to keep that. The concept of this project is to create a toolkit for cross-platform GUI development by controlling the browser rendering facility through Ajax calls. What does that mean is, imagine a user want to do something with a GUI that is cross-platform and can use this toolkit, or we're assuming that the user can use this toolkit to develop a program that provide a pleasant GUI using the browser rendering facility. So it doesn't focus on specific platforms implementation, except the server implementation. So the technology involved are, for instance, HTTP protocol, which is very common protocol for the web communication. Also with Ajax, which will be embedded in the HTML pages that are provided by the server, or during the development phase where you are designing the GUI and you're designing it into a HTML page, which will be processed in the toolkit. Also, the Ajax part is essential because you create this feature where you don't need to refresh the web page when you're using the browser, so it looks more like a GUI application rather than a web page. So HTML DOM is involved. DOM stands for Document Object Model. In this instance, we're using it to implement C++ package to support a service model for the HTML page, because there is a communication involved and the server needs to have this distributed instance of the HTML page without having all the browser facilities in mind. So C++ is involved, which is basically we use that to implement the server and the GUI model package, which is, as I said, of the HTML. Haskell is involved. We use Haskell to processing HTML pages and generating a HTML page with names that are mangled to for a server, and also it will generate a C++ package, and later will be loaded into the server. So the project parts for this project, I have a MVC diagram with all the parts replaced with the actual parts for this project. So here is we can see the user first. User sees the view, which is a HTML page or pages that is rendered by the browser. We don't provide the browser facility. Browser facility, we assume it's Chrome, but it could be any other browser. And the user can interact with the view via a trigger, which normally carried by the HTML event handler. And the trigger is a DOM events, and it has an AJAX call which sends a message with the event handler in mind. The event is a object in the DOM model that consists of the, for instance, consists what the mouse moves, where the position is, that kind of parameters. To the HTTP server, the server process it and have an AJAX response, which is again updated to the view. It's a very straightforward model for GUI. Here is the pipeline view, which is how a user might see it. So the user have a HTML page which serves as a description of the GUI. It goes through a package module, which it goes through a Haskell module, which generate two sets of files. One is a server blueprint, which is a slightly different HTML package with the HTML pages with all the names mangled, so that when you click an event, instead of calling the function directly, which is not implemented, it call a general function which just send the function name to the server, and then the server respond. The server respond, and then also when the user using it, it is visiting a HTTP server, and the server will be providing that generated HTML page to the browser so to generate a view. But another file set is a C++ package, a very small package, which will be loaded into the server, and the user will provide implementation for the functions that are involved, and it will serve as the GUI model in the previous MVC diagram. So here's the current page view, package view, which is will be this is the current. There are a lot of links should be there, but they haven't been implemented yet. Here is the HTTP server, which is I use the Dr. Fawcett's HTTP server prototype as a socket listener, but I just generally treat it as a black box, except for a little bit changes. It basically start a core handler, which is a callable object, and it start a server. The core handler is very basic. It generally provide any file spec that is specified by the GET request. We also process post requests for the function calls, but this is really a simple demonstration of general implementation. Also, I have a DOM Web API package, very small, and it's all shallow packages, has no function implementation, but just serve as the architecture for the DOM simulacrum, which is the generated C++ packages of certain HTML pages, of a certain HTML page. So the HTML page, the generated HTML page package will be rely on the DOM Web API, which is, and then it will be loaded to the server. And that's the first probing. First probing is server core functionality, which is very simple, like providing a basic web server. Here is the Dr. Fawcett's packages. It will display a demo like this. And if I click the button, it looks like a typical WPF demo. Actually, it is a typical WPF demo. I try to make this demo out of another demo, which is this demo, WPF demo, which is basically the same. But during the process, I found out that although this demo works fine, but normally when we're doing GUI, if we're doing it in this sense, there is no point ever to directly copy a demo from a WPF, because HTML serve GUI very differently. There's no point using a similar model. For instance, all the this actually. These are tables. I use it to model the grid model of the WPF. But it's not necessary, although it serves its purpose, because you still can change all the content act as a grid. It's not a grid; it's a table. So here.
WPF grid was modeled after the HTML table.
Oh, really?
Yeah.
I have no idea. Because it's really hard to use for a grid. But you get the tables. If you click the button, it actually has a Ajax call, which has a header. I'm not sure if this. That is the request is just a post method with a function name on it, and the response is a JavaScript. So whatever the response is, we'll call this method. We'll call this method, which basically evaluates any response text. Now, this is a very lazy implementation, but it serves as a demonstration of whether it works. And it's visiting the pages which is provided here. This is the supposed mangled page, and as you can see here, the on-click button actually does not call the button click. Instead, it's just calling a function called remote call, which is down below, and then it apply the button click as a parameter, and it basically send the button click as a string to the server. So the results, I say it's demonstrate that this method works, but it does not demonstrate that it works on complicated scenarios. That's what this project might focus on. So the second probing is HTML parsing and processing, which is there's something that there's some changes I made to the HTTP server work life. One is here for the HTTP message body. One was I was going through. I found out that it doesn't generate a correct content because the length is incorrect. So I found out that the original insert method actually start from the end instead of the beginning of the it's a vector.
I tested that. It worked for me.
It doesn't work for me because the content that returned from the server is all /u0, which is null. The length is incorrect. Yeah, if I change.
I was sending web pages through the body.
There are two functions, right?
Well, in the core handler, when you're getting the content, you're getting the file in the server, which is a page.
Yeah.
Message. Use that in the message. So the content will be the content of the file. Another change I made. That's here. So when the socket listener is binding, this method is, I think it's the Windows API for binding the nested interface. When it's binding the port, it has its endian swapped, which then provide a correct port number, so that
H-tons is supposed to do that. H-tons itself does that swap. But anyway, I'll be interested to take a look at what you have.
here that listen port and nested port is the same. If I get away, the nested port will
Yeah,
serve
if you
something.
just removed the H-tons altogether, you'd find they'd be the same.
Oh, okay, that's funny. I guess I noticed that.
Because netstat is always network order, but on a Windows machine, the endian order is different than that, so you would expect them to be different.
Huh. So I guess that's part of the implementation.
But anyway, that's
So for the additional parsing, so if here is the name is a Haskell module's entry point. If I provide it with a file, it will wait.
ramping.
And that's better. So it will generate, it would basically go through the HTML page, generate a abstract syntax tree, and then parse it. That's the parsing part, and then it will generate a header file for the C++ and a CPP file. It doesn't generate the name mangling file for now because I think that's the easy part. Also for the demo.pf HTML page, I already have a Mango name page that is manually mangled. So here you can see it generate up. This is the generate up with captures. Now captures means that when I was modeling the development phase of GUI. Normally, for instance, if you're in a WPF environment, the element in the view you want to interact, normally it has a name. So that in the main window, when you click that, when you type in that name, it shows that that element is inside this view. But for this project, it needs to be captured manually. So I use the ID attribute as the name, so that when we go through the file, it will capture, there are 3 elements that is captured. And they will generate a string, which is the argument for the constructor. I model that constructor using so it provides a constructor call with an initializer list, which can be called recursively. So for instance, the text block is a new element which has a tag div and has an attribute, one attribute, has a element as its child, which is a tag that called strong, and the content is the first WPF demo. This is a argument in the CPP file, and it's recursive, so that it's generated, so I don't need to worry too much about it as long as it's syntactically correct. And here, this large part is the document argument, which is when you're generating the whole document. The document constructor will have this as its argument because it's recursively generated. So as long as it
Basically, it's a recursive descent parser. What you're doing
for the Haskell.
Yeah.
I mean, Haskell is in.
I know
inherently.
I know Haskell is a
inherently recursive. So
functional language and wants to, but basically what you're really implementing is recursive.
yeah, for the C part, yes. So here's the capture callback, which is the function that is already here. Now the original page is different from the page that is served by the server, because this is the page that should be came up with by the user. You can see on-click here says remote button click, and the remote is defined, I guess, by the developer. It can be also defined by the user. So that every time it has a remote as its namespace, I know it's not supposed to be called by the HTML page, which is called by the browser, so that in case anyone want to supply the HTML page with a different script or with a different component, for instance, a graph, a visualization tool, that won't be mangled. So only this will be mangled. So here is the generated header file, which is, so what I did is I basically wrote a by myself, and then I modeled the template from that. So basically include all the library that it needs, which is the DOM web API library, and then namespace, I just make a demo, and then here is the very basic interface for document. With this demo itself is a HTML page which is inherent from the document, and then in private you can see here it has a button click function which will be implemented by the user. Also, it has 3 elements, which is the element that is captured. It's a pointer. The reason it's a pointer is because I still have not figured out how to make it the instance such that if you change that instance, it will be reflected for the whole document. Because this is is the part that HTML really is different from WPF, although I'm not that sure, because you can do recursive capture. The ID that you captured can contain a different element which also has the ID which is also captured. So here is the generated CPP file, which I don't think is readable. I just here. It's very simple. Just sort of include using namespace DOM and then just initialize with the document with the correct content. This is the constructor training with its private members initialized, and this text block is the private member, and then you see that this block is also a private member. And the button is also a private member. Here is the the document is the inherent base class. It initializes it with the whole page of the content, and it actually references the private member which is captured. And that's the probing, and it works on paper, and the generated page can be used in environments in a C++ environment, as long as we provided the DOM library, which the third probing is the DOM simulacrum, which is currently a very shallow library for the document object model. So I try to capture all the interface that is necessary for the demo. So it's really not that comprehensive. For instance, the attribute has nothing but two fields. Capture data which inherit from which string the text node inherit from has nothing. Here, this is the MWPF generated C++ package. This one is the template of that one. So you can see that the text block is not a pointer. The page for basic trying to see that it works around that. Basically, so we basically display the render. It will render the element and then display it. Attribute is an attribute. Text is the text. Element is element. Body is the actual. I just make it very. It is a very rather complex tree structure, and it can render accurately. And there is something that I want to mention about the DOM platform, which is it's the difference between captured and non-captured. So if I capture it here in the private member, it will be contextual, which means when the user is programming, this fields will be reside inside the document, the environment that the user is working on. If I don't capture it, I can provide the document models method, which normally people use that in JavaScript. You just document point get ID. The capture method currently does not work. I think it's if I put this into the C++ environment and run the same rendering, some of this element will be no pointer. I think it's because the order of the initialization is a bit strange. I mean, I can generate a list of initialization instructions with correct order, but I'm not sure which one. So there is this two approaches. One approach is I directly copy the phone so that anytime you want to use the text block, you just call get ID and it will return element. Or I put it here like what you probably see in the WPF environment. So that's the results for this. That's the results for this probing. And the summary is, here is the schedule that I use for the presentation, and it needs rework because all the parts for this project to work are different from what I expected. So although the probing process does demonstrate the viability of this project, so that it does work, it's just there are a lot of moving parts, and all those parts have different approaches.
And it's a cross-platform GUI, right? So which part of the code is essentially handling both the platforms, like, for example, say Linux and Windows here?
All the platform, as long as it can use browser, it can use this, technically, as long as I implement the server. I mean, I don't have to implement the server, but if that's part of the approaches that can divert this project. For instance, if I want to use the server, if I want to start this application from the server, I have to implement the server for each platform. So that when but if I want to start the application from a package, then as long as every platform has a C++ package, a library with server, I can just start the application and call the server, and then supply the server with corresponding protocol.
So mostly in this, essentially what you're saying in this approach is that the cross-platform handling functionality is being delegated to the browser as such.
Yes, right. And also the server implementation.
Your server implementation, I mean, the code till now which you demonstrated, so it's more of Windows context, right? I haven't seen any.
Yes, but as you can see, it's very tiny, so it can be implemented.
You can say like there'll be one more. I didn't get exactly which part of it you're going to implement if you had to port it to Linux. I thought it was
if I want to port it to Linux, all I need to do is write a tiny HTTP server for the Linux. But that's the development tool kit that I'm trying to provide.
In C++, you know, as long as you have the underlying library, the communication part, then it'll just compile on any of those platforms. You're implementing parts. I don't understand why you're implementing some of the parts you're implementing. You know, my model of this is different than your model, and I don't quite fully understand your model yet.
Okay.
So my mental model was that I have code, system code, some system I want to control. I want an interface for some system. Okay. And that if the system code is all written in C++, it'll compile on any of the platforms, because we got C++ compiled on any of the platforms. But the rendering, on Windows, if you want to render, you're rendering it with WPF, and if you want to, have an interface for Linux, unless we do something about it, we have to deal with WX widgets or whatever. So my mental model was that we've got this C++ tiny server. So here's a C++ system, it'll run on Macs, it'll run on, but now with a tiny C++ server, we'll use Chrome, and my model was that our tiny C++ server will serve up one web page, which is the interface on Chrome, and you click buttons or whatever, and with AJAX calls, you're just getting the system to do whatever you want to do.
Yeah.
Okay.
So I might be misleading for the rendering. The C++ render method just display the content. But the reason I want to do that is because I want to make sure that the elements implement correctly. That render method is actually not in the DOM, not in the DOM interface. So I'm not trying to render the web page. I'm trying to supply the pages to the user, which is a browser, and it needs to have direct control to the web page, which is why I need to make sure the content is correct.
What I don't understand is why you are building this DOM simulator, because the browser has the DOM, browser does all that parsing. Why do we need to replicate that before it gets to the browser?
So that when we have a web page, the page it will generate a package of the page, so that you don't need the parsing. Because normally, if I want to make it into a development toolkit, the user needs to have some knowledge of the HTML page, but it doesn't necessarily need to parse all the page parts.
I don't know why does the user need to know anything other than he directs Chrome at the tiny server, and the tiny server. So my mental model was the application, whether it's running on Linux or whatever, would spawn Chrome or whatever browser you want to use, would just start up an instance of the browser and feed it that web page, and there's the interface. So now the user just clicks the buttons and whatever he needs to do to get the system to do whatever he wants to.
Yeah, that's already been taken care of, which is
Why are you? Yes, see, I don't understand why you're building a DOM to do that. The browser has the DOM. The browser does the parsing.
Yeah, the DOM is not about parsing. DOM is about providing an environment for a user to manipulate a model in a GUI sense, model conveniently, instead of generating the pages by.
So,
for instance, if we're working WPF, we don't need to work it like WinForm model, which is initialize every page.
Yeah.
We just do the mangling of the actual method,
Yeah.
and leave the parsing, the injection.
See, my mental model is I'm doing everything that WPF was doing in HTML in the browser.
Or at least provide a similar environment.
He wants to
modify the GUI from
C++, adding attributes to the DOM,
like
right?
maybe add a button